In this video, we'll be looking at security requirements. But first, we need to understand about timing of security efforts first. So it is better to prevent problems with application security than to detect and respond to them after they happen. So that means before you release your software or application, try to address as much issues that you can find, which is much better than trying to address those issues after they get found by others, for instance, those attackers. So in terms of cost, it is usually more expensive to address them afterwards because you can think about like a software that is already available to users. If you have to update it, it's going to disrupt the service. For instance, like your operating system has to update very regularly, then you're going to be quite annoyed about that, right? So same thing with any other softwares applications that you release. You're trying to address all those security issues first and then try to release that afterwards. Okay? So this is primarily done through secure software requirements engineering and design. Okay? So we need to understand about what potential issues and security flaws we might face and needs to address as part of developing that software. Okay? And of course, those will be also captured through secure development and testing as assurance as well. But it is best to start early to ensure that you can mitigate as many vulnerabilities as possible. Okay? So that brings us to requirements engineering. So requirements are it defines what a system is required to do and the constraints under which it is required to operate. Okay? So you can define what it's supposed to do and describe its environment of operation. Okay? Requirements engineering is simply describing all activities involved in discovering, documenting, and maintaining a set of requirements for a computer-based system. So the act of doing discovery, document, and maintenance about requirements is requirement engineering. Okay? So the term engineering implies that systematic and repeatable techniques based on best practices should be used, not just an ad hoc give it a nudge and see if it moves kind of a approach, but you will have some sort of a procedure to follow and ensure that each step you complete set out tasks. Okay? And requirements engineering is the first step in software system development. So you need to understand all the requirements that you would like to develop. So here is an example of requirement engineering in picture form. So you can see that everybody has different perspectives on even the descriptions are the same. So even if you get the same description, the way people interpret it may be different, right? So in saying that, it is important that everybody understood what needs to be done and how it's going to be carried out for achieving what specific goals that the software application is trying to do. Okay? So that's why requirement engineering is really important. So a bit of a history first. Software engineering has historically considered security requirements primarily as non-functional requirements. We'll come to what non-functional means in shortly if you haven't covered it yet. But that's what it is. So software developers have recognized the need to integrate most of the non-functional requirements such as reliability and performance into the software development processes. Because if you think about reliability and performance, those are a few of the key attributes of the software that you need to provide. Okay, so security too often remains an afterthought. That means there are a lot of things that, as a software engineer, you have to carry out, and because there's quite a lot of things that you need to cover, security just becomes an afterthought. That's something that you like to do it later on. So there are a bunch of different non-functional requirements that you can specify. Things like auditability, extensibility, maintainability, and the list goes on. So whenever we describe non-functional requirements, these are the ones that describe some desirable characteristics of your software or application. Okay, so let's have a look at the differences. So when we talk about functional security requirements, it's a condition or capability needed in the system to control or limit the fulfillment of requirements. So these are quite explicitly described as to what they do. We'll see in the next slide. Okay? Non-functional security requirements are property of the system required to ensure fulfillment of requirements in the face of abuse or misuse. So when something does happen, then these characteristics as required will come into effect and provide fulfillment of requirements. So for instance, a denial of service attack has been launched against your server, then it is a requirement that the availability is still available for all the users that are using your service. So it doesn't actually specify how you can achieve that, but it specifies what you would like the application, server, or software to behave. Okay? And then there are derived security requirements such as not explicitly stated in the set of stakeholders requirements, so it's not written down, right? But we still need them. Okay? So these are the ones that we kind of assume that it will be provided for us. So for example, if we have an authentication system and you can specify as a requirement that password has to be at least X length long with these conditions, then from that functional security requirement, you can kind of say that, okay, we can derive that non-authorized personnel should not be able to access certain resources. So functional security requirements, they describe positive functional behavior related to security. Okay? And a good thing about functional requirements are that they can be tested directly and often related to security features like role-based access control, data integrity, etc. So here are a couple of examples. The back office users must authenticate with valid user ID and password. And you can test this by setting up a set of valid user IDs and passwords and trying to log in with using ones that are not valid. Right? 5 or more failed login attempts result in an account locked out. Okay, so you can also test this by trying to fail 5 or more times and see whether the system behaves how we want. Okay, so functional security, those can be measured. Non-functional security requirements, those are a little bit trickier because they describe the desirable states of your software. And they are related to generalized security needs. For example, audit logs shall be verbose enough to support forensics. Okay, so when we say verbose enough, that can be quite subjective, right? Some people might be able to understand based on keywords. Some people might need it fully spoken out or use specific words that may or may not make sense to different parties, etc. Right? All price modification events shall be logged. Okay? So it specifies the action, but it does not specify exactly what needs to be done about the logging. Okay, so do we need to log who modified it, how much it has been modified, etc. Right? Application shall achieve 99.7% uptime between 6 a.m. and 2 a.m. local time. Okay, and normally when we talk about uptime, it's measured in like annual terms, so maybe 0.3% of the time it could be down, but to test that, that's very difficult to do so, right? Because normally your development happens very quickly within a few months, and to thoroughly test the uptime, what you want to do is test it over a long period of time to achieve that, right? So those are not really testable as well. Okay, multiple database servers should be used. Exactly how many multiple databases? 2 is enough, or do we need 200? Transaction integrity, fallback, retry, etc. All of those, they do specify some actions, but for it to be a functional security requirement, it has to be measurable. So it needs to specify more details about how we can go about testing them. Okay, so until it is specified in the manner that it can be measurable, then as long as they describe the generalized security needs, then they will fall into a non-functional security requirement category. Okay. So security in requirements gathering, it is important to determine security requirements early on. Okay, so some key requirements to identify are related to assets. So what sensitive data or the assets will be worked with, who it will be working, so what actor roles will need to be distinguished, okay, and what levels of access to classes of data should be given to each actor role. So this is to control access control. Okay, so of course there will be more key requirements. So these are just some smaller subset list of those. Okay, so next question is, how can we generate these? You need to remember that at this stage we are just gathering the requirements and we haven't quite built our software yet, but still we would like to answer some of those questions. Okay? One of the answers that we can use here is a variety of elicitation techniques can be used. Okay? So let's have a look at some elicitation techniques. Well, the traditional approach includes introspection, interviews and surveys, and group elicitation. Okay, so those are the traditional approaches. However, as the thing gets more complex and size gets larger, those may not be applicable in those scenarios. Okay, there are observational approaches such as protocol analysis and participant observation, but this is given that what you can observe is all the possible states that you can discover. So if we're expecting some rare events to happen. For instance, the manager logs into the master system every 6 months, right? Then in the observable period, that may not be observed and that may not be taken into account. Okay? So there can be model-based approaches. So this includes like scenarios, use cases, and goal-based. And all those are good approaches to apply as long as you can characterize the system very close to what the real systems are like. So this is similar to when we were talking about security models. So we can use the model as long as the model reflects the real system as closely as possible. Okay? And there are also exploratory approaches like prototyping. So we can build as we go, try something, get some feedback, and throw away the original and iterating through. So a good elicitation techniques will involve choosing the most appropriate approach for the given scenario and trying to gather all the information as much as possible about some of the key questions that you will have to ask. Okay? So we're going to look at requirements gathering example. The example process that we're going to capture here is SQUARE, short for Security Quality Requirements Engineering from Software Engineering Institute. So you can find it there. Okay, and SQUARE specifies 9 steps to follow. And you need to remember that this is done as part of the requirements engineering. Okay, so at this stage, you haven't really built anything. You're just gathering information about what kind of requirements that we might need for the software that we're going to be developing. Okay? By understanding this, we can provide and implement security features much better than trying to address them later on. Okay? So we're going to quickly go over each step. So first one is to agree on definition. So as we've seen in the tiny pictures before, if we have different understanding of the same words or phrases, then there can be miscommunications and end up getting different results. Okay, so we need to first agree on definitions. Okay, get rid of the ambiguities such as access control. So what is your definition of access control? Okay, so from security perspective, you might be thinking it's a set of policies, right, that governs which users may be granted access to which resources. Okay? And that is probably what most of us might think, but from an engineering person's perspective, access control may be a software element in the system that actually implement this functionality. Okay? So the difference between the first one and the second one is that first one, we were thinking more like a verb, something that we do, whereas in the second one is a noun, it's something that it does, right? So we need to get rid of these ambiguities first of all, especially those common words that people may have different definitions. So what you normally have is an agreed set of like a dictionary that you can use, and a good place to start is to use public resources to reuse a comprehensive set of security terms. For instance, IEEE 610.12 standard glossary of software engineering terminologies, right? We also have different responsibilities. So as a developer team, you have to provide an initial set of terms, provide means for stakeholders to review and select a desired definition for each term, and document and share the finalized set. Okay? And as a stakeholder, you do the following. Okay? So you can read that on your own time. Once we cleared all those ambiguities, we can move on to the second step, which is to identify security goals. Okay? Goals are different to requirements, which I will touch in the next slide. Okay? So different stakeholders will likely have different ideas about which assets are important and the associated security goal. So this is more complex scenario where you have multiple clients. For example, you have the designers thinking about how to use this software for the design purposes, whereas some developers, they might have different ideas and so forth, right? So what you want to start with is a single business goal, and based on the business goal, you may derive multiple security goals from that. So here's an example. The system allows the client to make informed decision based on which assets are available. Okay? So that's the business goal. What we want to provide is the system to provide access to the assets they're authorized to access, and then make a decision based on that. So in terms of the security goal, from that business goal, we can attach the confidentiality, accuracy, and integrity of the system's data shall be maintained. Okay? So this is quite high level. Of course, we can make more concise and specified security goals as well. Okay? So once we specified goals, then we can move on to specifying the requirements. Okay? So goal is different to requirements. What we want to do in step 2 is to establish security goals, not security requirements or security recommendations. Okay? So what the goals do is they state what shall be. So you're describing the desirable state of your system. Okay? Management shall exercise effective control over the system's configuration and usage. The confident, that one we saw before, the system shall be available for use when needed. Okay? All those are describing the desirable state of your system or software, right? So you can think simply as the goals are describing a future desirable state of your system, okay? So when we later move on to requirements, specifying requirements, then the requirements state what must be done, okay? The system is required to have strong authentication measures in place at all system gateways entrance points. Okay, so this requirement can now map to security goals that we have specified, and sometimes a single requirement can map onto multiple goals, as well as goals being satisfied by multiple requirements. Okay, another example is a continuity of operation plan must be in place to assure system availability. Okay, so that is something that it must be done, right? That's not describing the state, rather it's describing what should be done about the system, which maps to the goal to satisfy. Okay. And finally, the security recommendations is about ideas that can be stated as part of the requirements. For example, invest in backup information technology hardware to ensure business continuity. So these are just the recommendations that can be included as part of the development process, but may not map to the goals. So here's the difference. So security requirements will map back to security goals. However, recommendations may not map back to the security goals here. Okay. So once we have the security goals, then we can look into developing artifacts. Okay. Artifacts are the ones that describes the functionalities of the systems. In order to do that, we need to collect a bunch of information related to the system, such as the system architecture diagrams, use case scenarios, misuse case scenarios, attack trees, standardized templates, and forms. Okay? Some may or may not be more suitable than others depending on what kind of system we are designing to do. Okay? For instance, if the system has a lot of functionalities, then we might be better using the use case scenarios to investigate how it may be how it may function, and misuse case to see how it can be violated. Whereas a smaller system, we can probably utilize attack trees to fully assess different metrics, etc. Okay, and then also verify the accuracy and completeness of all artifacts. So once we constructed our artifacts, perform risk assessment based on this. Okay, so remember, we still don't have the system built yet. We are using collected information to construct those, and then evaluating what possible risk that we may have as part of the system being developed. Okay, so to identify the vulnerabilities and threats that faces the system, we need to perform risk assessment. Okay, so this step is also useful to prioritize the security requirements at a later stage in the process. Okay, so what we need to achieve here is facilitate the completion of structured risk assessment and review the results and share with the stakeholders. Okay, and once we evaluated and conducted risk assessment, next item is choose the Elicit technique. Okay, so there are a bunch of them. We just have to choose the one that is most appropriate. Okay, so there are some examples of our best practices there, so that can be had a look. So now we can move on to eliciting security requirements. Okay, so even if the stakeholders are very knowledgeable about the project and communicate effectively, it can be challenging for the requirements engineering team to elicit correct requirements. Okay, so at this point, what we have is we understand about the system that we're going to build and its risks, its associated risks. And we have security goals that we have outlined previously before constructing our artifacts for security, risk assessment. Okay, so that's what we have so far. And from here, we need to elicit security requirements based on what we found. And to do that, we need to understand better about users' requirements, because not all security requirements that we come up with may be correct. For example, there can be non-verifiable security requirements that you cannot test or validate. The security requirements may be vague, and it also can be ambiguous sometimes, or even conflicting with others. Okay, so all of those requirements should be avoided to generate correct security requirements. So here is a vague one. A system shall improve the availability of the existing customer service center. Okay, you can try to rephrase this. Okay, but since there's much, I will move on. You can check that with me. So remember, requirements are concerned with what the system should do, not how it should be done. Okay. So once we derived those security requirements, what we want to do is categorize those requirements. Okay. So by categorizing security requirements, it gives us a good view about which categories may be lacking. So we can always revisit and try to ensure that all parts of the system are covered by security requirements. Okay. And also it can specify like the essentials and non-essentials at different levels to ensure that we can satisfy all the security goals that we have specified in step 2, right? So this table here is just a minimal set. You can always extend multiple columns as well. Okay, so just a reminder that since the goal of the square is to produce security requirements, the requirement engineering team and stakeholders should avoid producing architectural constraints. So that is based on the goals of producing security requirements. However, as a general practice, there will be some architectural constraints that you have to consider as well. That's why the column is still there. But as part of the square practice, we should not focus on architectural constraint column. Okay, and ideally, those anomalies will be identified and corrected in the previous steps of the process. Okay, so now once we have listed all the security requirements and categorized them, we can prioritize them. So this is due to lack of resources and time that often we're not going to be able to implement all of them. So using the informations from step 4, the risk assessment, and step 7, the categorization, we can try to prioritize some security requirements that we have generated. Okay, this can be unstructured deliberation. For instance, just based on informations from previous steps, we can select the ones that we think is most appropriate. However, there are some structured prioritization techniques as well, which can be looked in those other techniques. However, you don't have to know about them as part of this unit. Okay. So a question can be asked is, what to do with infeasible requirements? What do you do when the requirement cannot be satisfied? So something for thought. It will depend on the scenario, but for example, a simple solution maybe it's going to be left as a security debt, which means later on you may reconduct security risk assessment and to look at its impact and reassess how to go about addressing it. Okay, but of course there are other ways of addressing these, because the infeasibility is derived based on external factors, right? Maybe the goal is not achievable, then we may have to revisit the security goals to see whether those are reasonable or not for the system that you're trying to build, and revisit some other steps to ensure that this requirement can become feasible. Okay? And final step is inspect requirements. Okay? To create a set of accurate and verifiable security requirements, the goal is to find any defects in the requirements such as ambiguities, inconsistencies, or mistaken assumptions. Okay? So what you want to achieve here is to facilitate the inspection process by providing any orientation to the structured inspection technique or informal inspection guides as checklists. Okay? So by end of step 9, what you have produced is not the software, but security requirements. Okay, so those are the requirements that you're going to be using as part of your software development process. Okay, so it feels like a really long process as part of the software engineering practice. However, this is to ensure that you don't have to revisit these security issues later once the software is fully developed. Okay, so I will stop here. I think I'm talking too much. Otherwise, I'll see you in the next video. Bye.